Okay, 5.4 problem number 8 says, all schools driven by careerism are institutions that do not emphasize liberal arts. It follows that some universities are not institutions that emphasize liberal arts. For some schools that are not driven by careerism are universities. Wow. Okay, that's kind of a mishmash of words there. I'm not even really sure what to think about all of that. It's confusing. So my first step always is going to be to try to simplify things so that it's easier for me to understand the structure of the ideas that are being offered to me. Now I'm always going to begin to do that in the same way, which is I'm going to look to identify the conclusion. If I can identify the conclusion, that's going to allow me to do a couple other things that really allow me to simplify this argument. The way I'm going to identify the conclusion is I'm going to look for any indicator words. So words like therefore, consequently, hence, thus, those are all words that tell me what follows is going to be a conclusion. Similarly, words like because or since or for the reason that, those are going to tell me that I have some premises or some reasons that follow up. So why don't you go ahead and pause the video and look again at the words of problem number 8 and see if you can identify what the conclusion is by looking for indicator words. And then when you're ready, go ahead and restart the video. Okay, so looking at this guy, I see a couple of things that stand out as pretty important to me. One is the phrase, it follows that. Okay, that phrase is telling me that I'm getting ready to tell you something that's true based on something I just told you before that's true. In other words, I've drawn a conclusion about something. So the phrase, it follows that, is a conclusion indicator. Similarly, the word for is a premise indicator. So I know that the other sentence, all schools driven by careerism are institutions that do not emphasize liberal arts, has got to also be a premise, because remember, these categorical syllogisms have two premises and one conclusion. So now that I know what the conclusion is, I want to put this argument together into three separate sentences with the two premises appearing first and the concluding sentence appearing last. Okay? And when I do that, it's going to look something like this. My all statement is going to be first, and then I'm going to have a some or not statement appearing second, and then I have my some or not statement the conclusion appearing last. Now, the reason it's important to identify the conclusion first is that I know that the predicate term of the conclusion is the major term of the argument, and it's also going to appear in that first premise. Similarly, the minor term of the argument is in the subject position of the conclusion, and that's going to be in the second premise. So again, once I figure out what the conclusion is, I know what order to arrange my premises in, and this starts to make things much more manageable for me. So then my next step would be to identify my countable categories of things. When I look at this, I can see that universities is one of the categories of things. It appears the exact same way two times. But the other two terms are a little bit problematic. They're problematic because they don't appear exactly the same way. But I recognize that they're term complements of one another. In other words, schools driven by careerism is one term, and schools that are not driven by careerism is the term complement of that term. Schools that are not driven by careerism is kind of like non-schools driven by careerism. Okay, so that's my second term. And my third term is institutions that emphasize liberal arts. Okay, now I recognize again, institutions that do not emphasize liberal arts is the term complement of that one. So I got to identify my three countable categories of things, and I'm going to choose S to represent not schools driven by careerism, and then just use non-S when I want to say schools that are not driven by careerism. E is going to be institutions that emphasize liberal arts, and U is going to be universities. So now what I'm going to do is I'm going to symbolize this argument using those three letters, and I'll come up with something that looks like this. All S are non-E, some non-S are U, and some U are not E. Okay, this is much more manageable for me than what we started off with. We kind of started off with this word soup that was difficult to understand, but now I can really see clearly the structure of the argument. But what I have to do is I have to make sure that each one of those terms appears exactly the same way each time it appears. So I need to get rid of my non-E and my non-S, and I'll just take the first premise, and I'm going to consider the rules of conversion, aversion, and contraposition, and just go through those one by one and ask myself, if I convert this, if I avert this, or if I contrapose this, will I get rid of that non-E? So why don't you take your 4.4 handout, pause the video, and see if you can apply one of those rules to get rid of all S or non-E. I'm sorry, to get rid of the non-E there. And when you're ready to go, just restart the video. All right. So hopefully you realize that if you apply the rule of aversion to that first premise, you're going to have to do two things. And by doing those two things, you're going to get rid of that non-E and change it to just an E. The first thing you're going to do is you're going to change the quality but not the quantity of that statement. In other words, that statement's affirmative, so you've got to figure out a way to make it negative but also keep it universal. And there's only one way to do that, and that's to create a no statement, okay, an E claim. So if I avert all S or non-E, I'm going to get no S or E, because the second step in obversion is to replace the predicate with its term complement, and the term complement of non-E would be E. Now the second premise is trickier, because I recognize that if I convert, obvert, or contrapose that, I'm not going to get rid of that non-S. And you could pause the video and kind of play around with each one of those rules and see that every time you convert it or if you obvert it, you're only going to either keep the same problem or you're going to create more problems for yourself. And I'm not allowed to contrapose. I claims, so that rule doesn't even apply here. So what I want you to do is pause the video, and I want you to think about, is there a way to either convert and obvert this, or obvert and convert this, to get rid of, that allows you to get rid of that non-S. And then when you figure that out, go ahead and restart the video. All right, so the order in which I do this is important here. The first thing I'm going to want to do is I'm going to want to convert that second premise. In other words, I want to switch the position of that subject and predicate so that some non-S or U becomes some U or non-S. Because once I do that, I can obvert it. And when I obvert it, I'm going to, again, change the quality but not the quantity. So I'm going to keep it particular, but I'm going to make it negative. I'm going to change it to an O claim. And I'm going to have some U are not S, because when I obvert it, I change non-S to S. And then I have an argument that looks exactly like I want it to look, which is an argument with three categorical propositions with three terms appearing exactly the same way 2 times each. And now what I can do is I can apply my 5 rules. And I know that if this argument doesn't break any of the 5 rules, it's a valid argument. But if it breaks just one of them, it's an invalid argument. So my first rule says your middle term has to be distributed at least once, and the middle term is this one here, S. It appears in both premises but not the conclusion. Now if I look at any of my guides, I remember that E claims distribute both their subjects and their predicates, and O claims distribute their predicates. So the middle term here, S, is actually distributed in both premises, so the first rule is not violated. We passed the first rule. The second rule says that if there's anything distributed in the conclusion, it's also got to be distributed in a premise. And I look down here at my conclusion, and it's an O statement. And I know that O statements distribute their predicates. So E is distributed, which means that it has to be distributed in a premise, and it is, because E claims distribute both their subject and their predicate. So I'm good so far on my first 2 rules. I passed them. Now the third rule says I'm not allowed to have 2 negative premises. And this is where we kind of run into our wah-wah problem. Because my first premise is an E statement, and my second premise is an O statement, and those are both negative. Okay, so this argument has violated the third rule, which means it's invalid, and the fallacy is exclusive premises. Now, if I don't like working with the rules, or I want to check to make sure that I'm actually applying the rules correctly, I could come over here and create a Venn diagram for this guy. Okay. Now remember, what a Venn diagram is doing is it's trying to show what the Venn diagram would look like when the premises are true. And if the conclusion shows up after diagramming in those 2 premises, then we know the argument's valid because the conclusion has to be true and the premises are true. But if the conclusion doesn't show up after diagramming in the 2 premises, the argument's invalid. So I'm always going to begin with my universal premise, no S or E, and I'm going to come over here to my Venn diagram, and I want to show that there's no such thing as an S that's also an E. There are no S's that are E. So maybe pause the video and think about what numbers, 1, 2, 3, 4, 5, 6, or 7, I'm going to have to shade in order to show that no S or E, and when you're ready to go, start the video. Okay, I want to show that no S's or E, and there's only place where S's and E's could coexist, and that's right here in areas 3 and 4. So if I want to show that no S's or E, well, first I got to get my pen working here. Oops. I'm going to have to blank out areas 3 and 4 because that's an area where S's and E's would be together. And I'm trying to show that no S's or E's. So I'm going to color this whole area of 3 and 4 in and eliminate it. Kind of turn out the lights, show that there's nothing there, no S's or E's. Now I've got a diagram in my second premise, and I can see that it's a sum statement. So I know I'm going to put an X somewhere, and I have to decide in these open areas here, where's a place where an X could go. So I'm going to show that some U's are not S's, and I recognize that U's could be in 2, 5, or 6. They couldn't be in 3 because I blanked that out. So if I wanted to show you that some U are not S, I have to figure out a way to put an X somewhere where there would be a U that's not also an S. So if I put an X in 2, that would be a U that is an S, and I'm trying to show that some U are not S. So I'm going to have to put it in 5 or 6. But I don't really have any reason to choose 5 over 6 because whether it's in 5 or 6 means that that's a U that's not an S. And when I have 2 possible places I could put it and I don't have any reason to choose one over the other, I got to put it right there on that line. And again, anytime I have an x on a line, I got a problem. All right? So I've just shown this argument to be invalid by two methods. The rule is that it breaks is exclusive premises.